Okay, so in this video, we're going to discuss thermochemical equations. So I have an example reaction up here, right? Just a chemical equation, nitrogen gas reacting with oxygen gas to give us nitrogen monoxide. And we call this thermochemical equations because now we've added in the enthalpy, right? We've discussed enthalpy and what enthalpy is now. We know it's a form of energy and exchange of heat as a reaction happens. Well, we would measure the enthalpy for this reaction to be 180 kilojoules. Now, what does that mean with regards to our reaction? That means if I take 1 mole of nitrogen, I'm going to get an enthalpy of 180 kilojoules. Okay, well, we could say 1 mole of oxygen is going to give us 180 kilojoules. 2 moles of oxygen is going to give us, 2 moles of nitrogen monoxide is going to give us 180 kilojoules. So we see that this is going to be dependent on amount. Now, what if we were to have this reaction, but each of these coefficients was multiplied by 2? So we had 2 nitrogen reacting with 2 oxygen gives us 4 nitrogen monoxide. What would we say happens to our enthalpy? Okay, it doesn't just stay the same because we now have double the amount of nitrogen and oxygen reacting to give us double the amount of nitrogen monoxide. Well, enthalpy would tell us that we should get double the amount of our change in enthalpy. Remember, it's heat. If we double the amount of something, we should get double the amount of heat exchange. And so we'd see this would end up being 360 kilojoules. Okay, so we've taken an amount of our reaction and we've doubled it. And we said we should get double the enthalpy. Well, what if we took the reverse of the reaction? So let's say we took this reaction and we went ahead and we flipped it. Let's say we had 2 NO going to N2 plus O2. Well, now we have the opposite happening in our reaction. Now, if you go back and you remember, enthalpy is a state function. So it doesn't depend on the path, but it depends on the starting and finishing points. Well, if we flip the starting and finishing points, we should have the opposite change occur. And so we would see here the enthalpy change would be inverse and opposite to our 180 kilojoules. Okay, so we flip a reaction, we see it changes the sign. We can multiply all of our coefficients by a specific amount. That same amount is changed by our individual enthalpy from our original enthalpy. Now, what happens if we go ahead and have like a real reaction where we say, well, we produce this mass, so we use this mass, because we don't usually talk about molar amounts. Let's say we go ahead and we produce 3 grams of NO. We want to go ahead and figure out what would be the enthalpy change, right, or the heat exchange for this reaction. Well, we can start with our NO, so 3 grams of NO. Well, we only know a relationship between our enthalpy and a molar amounts. Okay, so kind of like when we convert between molar amounts from reactants to products, we can do the same thing here. And so we would first need to convert our NO to molar amounts. Okay, and now we can see our mass cancels out, and we would want to go ahead and then convert the NO amount that we're actually reacting, right, the 3 grams to moles, by the ratio that we have from our reaction. So we would see 2 moles of NO is going to give us an enthalpy change of 180 kilojoules. Right? Now, once we go ahead and we do our conversions here, we would see we would have our enthalpy change be 9 kilojoules. Okay, so we see as we're kind of working through these thermochemical equation reactions, there's different ways we can manipulate our reactions, and we see that that affects our enthalpy, whether we change our coefficients or we flip the reaction. But we can also take it with a mass or amount of a reactant or product that we use or is produced, and then compare that to what we would actually get for our enthalpy change. So hopefully this gives us a good background in our equations and how that relates to enthalpy and how we can use enthalpy in order for us to calculate heat when we see that we get to those are equivalent.